Okay, we're going to talk about intercept form, slope, and y-intercept. So let's go over y-intercept first. So y-intercept is the y-coordinate of the point where the graph crosses the y-axis. We can think about this in three different ways. We can think about it algebraically, graphically, and numerically. So algebraically is we're looking at an equation and pulling out the y-intercept from that equation. So the equation that we've looked at so far is intercept form, which looks like this: y equals a plus bx. Y equals a plus bx, where a is a constant number and b is the coefficient of x, the number being multiplied by x. So in intercept form, this constant number is the y-intercept. So constant is the y-intercept. This is just in intercept form, which is, it looks like this. It has that y on one side and then equals a constant plus a number times x. And again, this constant number here, that a, is our y-intercept. So now let's take a look at the graph. How does the y-intercept show up on a graph? So the y-intercept is, again, that y-coordinate of the point where the graph crosses the y-axis. So where does this graph cross the y-axis? It crosses it right there. So I want you to think about anything on the y-axis is going to have an x-coordinate of 0. So if I'm on the y-axis, I'm not moving left or right at all. So my x-coordinate is going to be 0. Remember, x comes first, and then that y value will be whatever a was in our equation. So I'm going to write 0, a. And that's the point of the y-intercept. All right, now numerically, let's think about how we'd find the y-intercept. So the y-intercept, another way to think about it is it's the y value when x equals 0. So on this graph, x equals 0 only at this point, only here. And the y value when x is equal to 0 is our y-intercept. So if I had an input-output table, I'd be able to scroll through my numbers, and when x is equal to 0, the y value that corresponds with it is the y-intercept. So y equals 6 is the y-intercept. Okay? All right, now let's take a look at slope. So our slope is a number that represents the steepness and direction of a line. Steepness and direction. Algebraically, we look at intercept form, and b, this coefficient of x is our slope. So coefficient of x is the slope. Now, let's look at a graph and see how the slope shows up there. So I wrote up this formula for slope. Slope equals b, which equals rise over run. Another way to think about it is it's the change in y divided by the change in x. Change in y over change in x. So if I'm pulling the slope, if I have to find the slope given a graph, then what I'm going to do is I'm going to pick 2 points on my line, and I'm going to look at the how I'm going to move from here to here. And what I'd have to do is I'd have to go up, I'd have to rise first, and then run. Rise, run. The rise is my change in y. So the change in y values, remember this is my y-axis. How much am I moving up and down? And then the run is the change in x values, change in x. Rise over run, rise over run. Change in y over change in x. Something to note about the slope. So a positive slope is going to look like this. It's going to move upwards from left to right. And conversely, a negative slope is going to move downward from left to right. Okay? And then there's two other types of slopes, two other types. I have a horizontal line. So that's not moving up or down, it's just constant speed. Not necessarily speed, but constant, it's flat. And then I also have a vertical slope. Again, that's not moving up or down, so it's not positive or negative. So we call this kind of slope a zero slope. And then this vertical line, we call that undefined. Undefined. So positive, negative, zero, and undefined. If we have a positive or a negative slope, we're going to have something that looks y equals a plus bx. For a zero slope, we will have just y equals and then a number a. And then over here, if we have a vertical line, our equation will look something like this. X equals some number, call it c. Okay. So 4 different types of slopes that we can have. Each, these two will have a similar looking equation, y equals a plus bx. In this case, in the negative case, the b would be negative. Maybe I should do that. So a positive slope would have an equation that looks like this. And then that negative slope would have an equation that looks like this, y equals a minus bx. And then a zero slope is just y equals a number. And then an undefined slope is x equals a number. Now let's look at the numerical way of finding slope. So if I was given an input-output table, how would I figure out what the slope is? Again, the slope is equal to the change in y over the change in x. The change in y is going to be taking one value of y and subtracting another. That's what that y2 minus y1 equals, or that's what that means. And then x2 minus x1 would be taking the corresponding x values and subtracting those. So let's call this x2 and x1, and then this will be y2 and y1. So what I'm going to do is I'm going to subtract y2 minus y1. So b equals y2 minus y1 is 5 minus 6. And then I divide that by x2 minus x1. So negative 2 minus 0. 5 minus 6 gives me negative 1. And negative 2 minus 0 gives me negative 2. Negative 1 divided by negative 2 simplifies to just 1 over 2. And that will be my slope.